have a live stream of our class now. So if you do want to stay home, that's entirely up to you. That is within the recommended guidelines to just stay home if you're feeling sick, right? You can let us know by email or send me an email that you're not going to be able to make it in, or you're not feeling well, or if you have childcare at home. I've gotten a couple of emails already about that. So I'm going to post a live stream. You can't see it here, but I did post onto the classroom today the link to the live stream today. I'll post it every day. I'll post a link to the new live stream, or maybe I'll just let you guys go to the YouTube and find me. That's I would hit that subscribe and like button, like and subscribe.
YouTube page.
So I do have a YouTube page that you can access the classroom. I don't know I don't even know how to find my YouTube page.
I think we just have to. Well, last class I was in was
Let's see if I can find me right now.
yeah.
Let's see. So if I search John Ram, let's see if that works. Oh.
We go into the school, click it on, and then it should be in the blogs or something.
Yeah, maybe I'll send. Let's just try. I might not be searchable. That's the other problem. Yeah, it looks like I'm not really that searchable. There's another genre that's not me. Let's see if we can do filter. Can we find person?
Channel.
There we go. There you go. So if you do type John Wren, you can find me. You can see me and my son Charlie there. That's me. And I've got 45 videos already. Look at that. Okay. So this is live, right? You'll see a live now when you go there. I'll just post my whole channel maybe to the classroom next. And I'm going to try, you'll be able to track the videos this way. You can get in there and see what's going on. This one's on right now. So on the other channel.
Subscribe.
Excellent. If I hit 1,000 subscribers, I can stream on my phone. So I have no idea how you hit 1,000 subscribers. I don't want 1,000 subscribers, really. Okay. I just think it's ridiculous that I can't use my iPad. Anyway, so I will post everything up there. There'll be also supplementary videos up there. Also, you have the Khan Academy classroom. So we will be able to keep going through content if you have access to a phone. If you have access to the internet. That's what I'm most worried about. Is I don't like that. That's the biggest impact here, is that that students will not be able to access.
By the way, we just figured out certain things you guys post can't be open on the.
Really?
Yeah.
Interesting.
Apparently, my last class, it was school stops Friday. So we got March to the 27th. Are you still live streaming?
Yeah, so I'm going to be live streaming all next week. Then I'll take a break for spring break, and then I'll come back and I'll live stream the next week as well.
And
so
after April 10th, it's just all by
hopefully everybody will be back in classes around that. At that, I think it's April 14th is the day after, or April 13th or 14th. That's like, because Good Friday. They think they're going for that Good Friday weekend, and then the
by year.
Which seems like probably really going to be a problem too, because like Good Friday and that whole like weekend's going to gather a lot of people together, and they're going to be, rubbing hands again. So I don't know. Yeah, we'll see. We'll see what happens. Yes.
This is what I'm talking about. See, look.
Oh, there should be down here. You'll see your work, so you can click on that, and then that should open somewhere.
Nope. Sometimes it doesn't open. Certain.
Yeah. If there's work attached to an assignment, it will be under the little arrow. There's like at the bottom of your page. Usually there's an arrow, or if you use a computer, you'll see it up in the corner.
Like with mine, like the problem we had here.
Yeah.
So I could just use my Wi-Fi or data at home.
Yeah, I'm hoping. Last class, I actually had 5 people watching, and they actually submitted questions in my Chem 40. So there are 5 people that are already stuck at home. They have kids and stuff like that. So they're watching from home, and they actually submit questions, and we did it up on the board. The chat will be active the whole
Yes.
time.
So
So-
East Methodist has the warning, Alberta, they
Yeah.
have warning, but no warning at all.
Yeah, so at least you guys are going to get a little bit of time to kind of adjust, and if you you start to get any symptoms, right, just stay home, and we'll try to
What are the
socially
symptoms?
distance as much as we can. Keep yourselves at an arm's length apart from each other. Feel free to take advantage of all the free tables in the classroom today. There's going to be lots of space. Yes.
Lots of space on the buses too as
Oh,
well.
I bet the bus must be just empty. It's the last place anybody wants to be. Imagine.
Winnipeg Transit
I don't
shutting
pay
down.
attention to that to me, but what are the symptoms again?
Well, I'm not sure. I'm not. They're very flu-like, which is one of the problems. Like
Sore throat.
sore
It
throat.
has
And,
the same symptoms as a flu, maybe a little bit
It's
less.
more hard breathing and stuff, I guess.
yeah, the problem is, we don't have very much resistance to it, and it also spreads very quickly. As far as I understand, its danger level is similar to the
Wait.
flu,
Is it 9
But-
people that have it here?
but it's that it spreads so much faster because we're not ready for it.
And
Like,
plus, people, they're putting it way out of proportion.
Mm.
Now people are ransacking places, taking all the stupid toilet paper. I'm gonna
That's-
go out and buy all the punch and say, 9 for 9, people.
I find that stupid. Why toilet paper?
And why toilet paper?
That's what I said.
It's
apparently, there's talk that the toilet paper factories are going to close down.
Really?
Really?
Because they're all in countries that are affected. So that's what I heard is why people are buying it up. I thought they were just buying it up because diarrhea is one of the symptoms.
I know.
But anyways, we're live, so we should probably do some work. We've got
Oh, your live stream heard diarrhea.
yeah. There you go.
Nice.
I'm gonna get flagged. I did post that it's not a child stream, so it's okay.
That's why I posted on Facebook that the great portfolio.
So we've gone through the various chemical reaction types, and I do need these to be memorized at some point. So we have synthesis. That's when two become one. So two separate chemicals become one chemical. That's what we're going to call synthesis. Decomposition, when one becomes two. One becomes two. Decomposition, breaking down. Single displacement, where there is only one pair and one element. And so the pair and the element switch partners, and then you always have one element on each side. So here is this is the reaction we talked about the other day, the thermite reaction. So aluminum plus iron oxide, or aluminum plus rust, becomes iron plus aluminum rust. So or aluminum oxide.
I like that explanation before that when I was in that class. It's like two cells go with another cell and then they switch and switch. That's when we
Sure, yeah. I also like it's a couple.
Yeah,
and you
that's
have
what
the
I mean.
third person
And
comes
then
in
that's
and they
what I
break
was
up the
talking
couple.
about.
Yeah,
And
okay,
then and then they switch and then the one is all alone.
Right, yeah. If you've got a couple and then they got the new.
And the other
New
one
person comes in.
Yeah.
They can't stay. They do not become a throuple. That
No,
would be
they
synthesis.
split apart.
They break apart.
Yep.
Then the last one that we discussed just the last like seconds of the day on Friday was, or on Thursday probably, was the double displacement reaction. So in this case, you have two different couples, and then they do a sort of a swap. So the iron is still here, but now its partner is sulfur, and the potassium is over here, but its partner now is chlorine. So they have done a swap. So that's the double displacement. So two couples, and
that's
then
the kind of joke
swap.
you made, but
wife swap. The reality TV show called Wife Swap, where they used to send one wife to a different city, and you know, she's really clean and this one's really messy. What's going to happen when they switch partners? Yeah, so that's exactly it. So the final one, which we have not talked about yet, is combustion. So this is a unique decomposition reaction that we find in, or is it decomposition? It's not quite a decomposition. It's not quite a single displacement, but it is the form where we react with oxygen to form CO2 and H2O. So any organic compound we can take, we can pretty much burn anything if we want to. That's organic. That means it's made of carbon and hydrogen and oxygen. And the result will be the formation of CO2 and water. So here's two examples. This is the burning of methanol. And then this one is butane. Butane. So butane lighters, that's butane there plus oxygen. And you get 8 carbon dioxides and 10 waters. Methanol and oxygen, you get 2 CO2s and 4 waters. So this one can be probably the hardest to balance. If I ask you to balance a combustion reaction, that definitely is the most challenging one because you have the most different moving parts. You got lots of carbons, lots of oxygens, lots of waters there. But you can always identify it because it's a reaction with oxygen and carbon. And it always produces the same products. So notice it's always CO2 and water. Okay, so let's look at this practice section. I'd like you to look at this right now in your booklet. All you need to do is identify them as either synthesis, decomposition, single replacement, double replacement, or combustion. You could use some quick labels like S, D, SR, DR, and C if you'd like. And then you can go through and identify them each. So let's just do the first one together. Zinc plus oxide, oxygen gives us zinc oxide.
Single?
Okay. Are there any pairs at the beginning?
Yes, there is.
There's no pairs here, right? There's only 2 separate elements, but those 2 separate elements became one element. So synthesis, yeah. 2 became 1. So this is going to be our first synthesis here. So you can just write a big S if you like.
Yeah, that's it, right.
Or synthesis. Okay, I'm going to give you a second. I'm going to walk around and check out how it's going. Please try to do the remainder. And you can do this at home as well.
I forgot how to do this again.
So 2 become 1, synthesis. 1 becomes 2, decomposition. 2 and a 1 become a 2 and a 1. That would be single replacement. 2 pairs, double replacement. Oxygen, carbon, combustion. So this is on page 26. Back here.
No, that's not deacon.
Might as well pass this one out too. What we got here. In preparation for the impending missing a class, I will give you book 3 on chemistry right now. So you can put those in your notes. Next week you can use that book. I actually am hoping to start the next unit, but I'm not sure how it's going to go. Oh, that's it. There you go. We'll see. Of course I just locked it. If we only finish sorry about that. If we finish 2 units this year, that's good enough. There's 2 essential units. So
Wait, are we in science or chemistry?
this is science.
Okay.
This is the chemistry part of that science course.
Oh, okay.
The next section will be about, well, I'm not sure. I haven't decided if we're going to go biology or we should go straight to the next most important unit, which is the physics unit. But the hardest unit to teach from distance. So maybe we should go to environmental science.
Is that the evaporation and stuff like that? Or is
Yeah,
it
maybe I will. I'm going to send the environmental one away right away and then.
photosynthesis kind of deal? No?
Yeah, it's got like photosynthesis and stuff in it.
Okay.
Matthew, what's your email again? You want to come over here and for your Gmail? This one. This one. Okay. I'll send you the folder that has all the stuff in it, and then I've got it right away as soon as I type the first 2 letters. Oh, that's 20E. Never mind. You don't need that one. Oh, yes. You want, if you have a chance to go. Guess I'll probably think acids and bases probably will take 2 weeks just because it's going to be that way. So I'll come back right away. Hopefully I'll walk into the yeah. So this one. This is the carbon and oxygen. So that's another sorry. Oh, yeah. It's actually the same reactions right here. Okay. So here we have 2 things that's and it's here we have 1, but it's 2. So that's yeah, 2 different separate things and 1. That's 1 thing becomes two things. It's like it's breaking apart. And then here you have one single person mixed with a couple. And then a new couple, and a new single person. Single replacement. Single pattern. I have two couples as well. Double couples. There you go. Here's the new singles. And this is also singles, because you have two becoming. So in a way, you don't have to even think about what you're reading, right? In these kind of reactions, we don't have to really think about reading it as like things. Like you don't need to know what we're looking at. Just think about how you have two things here, and they became one thing. So two becoming one, that is a synthesis. They could be black boxes. I don't even need to see the chemicals. Like I just need to, two things became one. I don't need to read the labels. And here we can think about this as like, this is a big square became two little squares. Right? It doesn't actually matter what it says, but one thing became two things. So that's decomposition. That's a breaking down. In the next one, we have a single thing, and then we have some sort of pair, right? I don't know how to do this.
It was.
Maybe like a triangle.
It's a single, but it's split in part.
Single replacement.
So when we're identifying chemical reactions, it actually doesn't. We actually don't care about the chemicals, which is weird, right? We're just identifying kind of by parts that are moving. So here we have one single piece by itself. We have a pair of things. Then we get a new couple and a new single at the end. So that would be a single replacement. We've only replaced one of the two couple partners. What do we think about E?
Say double.
One option. Double replacement schema is an option. Does magnesium start with a friend? Magnesium starts with the third wheel to this date, right? But then it ends up going home with sulfate. So that is a single. How many people have been replaced? Only the hydrogen has been replaced. So only a single replacement.
Okay.
Sodium and sulfate go out for the night with barium and nitrate. And then two replacements happen. So what is that?
Double.
Double replacement.
Oh,
Replace
reverse
partners
it.
for two different compounds. And then the last one looks like some sort of weird synthesis, maybe something's happening there, but we do see carbon and oxygen, so we should say combustion. And if you're at home watching this, then feel free to put questions in the chat. I'll try to address them right in class. We had someone check and they said it was about like 10 seconds delayed. So it's pretty good stream. Like it's so next week, all of the classes will be streamed, and then you'll have spring break, and then the next week after that, all the classes will be streamed, and then you'll come back. And hopefully
When do we come back? It's very confusing. Some say the 9 or no 10. Some
current.
say the 12,
Says the 14th.
and some are saying that no.
Let me pull out the calendar and I'll see. It's I believe the 13th is a holiday Monday, so I'm not sure what they're gonna do for that. And we don't have the holiday on the 13th usually, but like it's a holiday in Ontario. That's Easter Monday, so I believe that is the 13th that we're allowed to be back in the building
Okay.
because the 12th is the Sunday. So we're obviously not coming back to school on Sunday, but the Sunday could be like the last day of the quarantine, and then 13th. I'll check my email. See, anytime you hear one of those email sounds, it's because I get an email every single day, or every single like minute right now. Look, they just made a new absence code for you guys. If you're away, they want retroactive 14-day isolation. So if you've been out of the country in the last 14 days, you're supposed to go into isolation. Let's see. What is MTS one?
And my cousin, she works with the Health Science Center. They sent her to Taiwan. Then she has to go through a screening every single day just to get back into the Health Science Center.
Yeah, I bet. It's crazy. What is the date today? The 16th. There's a new bulletin.
The new email.
I'm just checking the province's website.
Oh,
Yeah. Oh boy. Yeah. Hey. I think it's. Yeah, I feel like there is a mistake. Up to.
Yes, I agree.
Right, because you need an extra. Yeah, so that one's just not gonna work.
Yeah.
It's gotta be. Yeah, I agree. Bulletin 19.
before we get quarantine, can I do those masters like we talk about?
Sure, yeah. I'll start just sending those home. Yeah, is anybody not done? Who is missing from Mastery Moment 1? Yeah, there. Okay. So I'm just gonna send those home with you now because we want to keep you safe as much as possible. So try to do these at home and bring them back. Yeah, and I'm also posting some live streams now too. So, on YouTube, that you'll see posts. And during class time, there'll be a class online. Dan, did you get the notification? Okay. Okay, so next week, or for the rest of the week, you can send us those. So next month. So, this week. At noon, I'm gonna post a live stream for Google, so if you go to the library, you can watch it. I'm not sure where I do it. It's simple, but they'll find Florida, all recorded closets. I'll probably keep posting things classroom, which I know is not my favorite. So we'll have to figure out how to do that. That's definitely yeah. Let me think about that. Maybe I can forward you the build up. You did this one, right?
I'm not quite sure. Better safe than sorry.
Thursday or
Oh, yeah.
Yeah.
I just looked at it and was like, oh, yeah.
Why did you do this one? No? You can bring it me tomorrow?
Is that it?
Sure. I don't believe, we're trying to get away from long tests in our class. So I'm going for as short as possible. Okay. Here's more classification, but this one has some balancing. So actually, this is probably a good place to go right now is to do these ones. These are also balancing questions. So this is likely what will happen is that the next time we do sort of a check-in or whatever, it'll include balance these chemical reactions, identify these chemical reactions. So maybe let's do one together. What should we do for this first one? We've got calcium hydroxide plus hydrogen chloride gives us calcium chloride plus water. Remember that brackets means we have to multiply by whatever's on the inside. So I'm going to do a little bit of work here with one of these bracket questions because we haven't played with them too much. I'm going to put calcium down here. I'm going to say there's one right now, and there's one here. For oxygen, I've got 2 times 1. And for hydrogen, I also have 2 times 1. So actually, I'm going to I like to try to show that they're together, so I'm going to do something like this. And then I also have a extra hydrogen down here, right? And a chlorine, which I can't get my chlorine in here. I don't have the printing small enough. Okay. Remember, we try to bracket things that are together. If we can. In this case, I'm going to have to do like a super bracket on here so that that's all together.
Put 2 before the hydrogen chloride.
Start. So if we put a 2 in front of the hydrogen chloride or the hydrochloric acid as we know it, so put a 2 here, that will make both of these numbers 2. That sounds like a really good start. That balances out the chlorine at least. And then I'm just going to look out for my totals of hydrogens here. So I've got 2 times 1 hydrogen, that's 2. 2 times 1, that gives me 4 hydrogens. I have 2 times 1 for oxygen. I got 1 oxygen. Okay. Over here, no, I have 2 oxygens. 2 oxygens, sorry. And then on this other side, I have only 2 hydrogens and 1 oxygen. So how could I fix that? So someone gestured at me to put a 2 in front of the water, and this would give me 2 oxygens and 4 hydrogens. And we have the 1 calcium at the top. We have the 2 chlorines down here. We now have 2 chlorines down here, and we have 1 calcium. So we are balanced. Let's try to fill out a page. Okay, yeah. So schools, I just found the notice. So schools are closed till April 10th. So that would allow us to come back any day after the 10th, which 10th is a Friday. So we're definitely not coming back on Friday.
The 13th.
So the 13th is the first day. I think that in Manitoba, 13th is not a holiday, so we can open school on the 13th. But you'll have to wait because that'll be that'll be something that we notify you about, I imagine.
I
This
said
was
that
another
might-
reason to make sure we have your email addresses. Hopefully you all filled out those little yellow forms. If you want to stop in downstairs. If you're not getting the emails lately, you should have gotten like a bunch of emails this
Yeah.
weekend. If you didn't get a bunch of emails this weekend, then stop by the office and have them update your file. I don't have the ability to edit your file, so I can't do that update myself. If your Google Classroom's not working yet, then we gotta make sure that's working too. And if we have to, we'll call you. But, definitely with whatever we have, 600 students or whatever is, we have to depend on email mostly. I think School Messenger can send text messages now, actually. So maybe we can send you a text message. It's not the most exciting stream in the world to watch here. Shrink this all a little bit so I can fit my next question in here. Okay, so let's look at what type of reaction do we have? We've got calcium hydroxide plus hydrogen chloride gives us calcium chloride plus hydrogen dihydrogen oxide. Correct, that would be a double replacement. This one is actually a tricky one to look at for double replacement, but think about it that like these two parts here, here's your calcium, and part of this is the OH. And then here we have our hydrogen and our chlorine. Chlorine's over here. And then there's also one hydrogen that came over from that other hydrogen chloride. So it is a double replacement, even though it looks like it might not be. But one of those hydrogens is hidden in that H2O. But if you could put labels on your atoms, you would see that double replacement action. How about this next one? Can you identify it right away? What is it? Double, single, combustion? Single, yeah. We see the single friend here and a single friend here at the end. And then we're going to do some counting. We got one potassium, two hydrogens, and one oxygen. One hydrogen and one oxygen, and then two hydrogens. So we have a problem. We have too much hydrogen. In these cases, I usually look and I see that on this side, hydrogen is an even number, and on this side, hydrogen adds up to an odd number. So I would usually try to target that and get rid of that odd number. So I would probably use a multiplier on my odd number to make it even. That's usually how I start. But that's the only thing that's out of balance, right? You could try balancing this, but it would be you couldn't balance from this side because you have less than you have over here. You could go to 4. So you can multiply by 2. That would be another option. Multiply this one by 2. Have 4 hydrogens and 2 oxygens, and then see if you could catch up. Here we go. Also remind you all to make sure you're on to those Khan Academy classrooms. There's lots of good videos on there. I believe the link is still posted in the at the top of our Google Classroom. But if you just go to khanacademy.org and go sign in with Google, you can sign in with Google using your school account. And then once you sign in with your school account, you'll see that I have posted assignments and videos for you to watch using that school account. And it's probably the time to put some extra videos up there, honestly. So, Khan Academy.
Oops.
And once you're here, you can see the login button. Go to login. See the continue with Google. So clicking on continue with Google, and it'll send you to the Google webpage where you can use your school login. Mine's already logged in, so it's going to log in pretty quickly. And there it goes. And I'll still be able to see myself. This is my student ID, right? So, and then for your class, you have a 20F class here. And I've started posting, I posted some assignments. I see that many of you are on here already. That's great. I can see who's been reading stuff, and I can assign extra things. So I'm going to go to my chemistry unit here. We did those already. So chemical reactions. So we make sure that balancing chemical reactions on there. Stoichiometry is not necessary. So that should do it. And then the types of chemical reactions. Nope. We can assign that one and that one. We don't need to do those other ones. Great. And we're going to eventually have the acids and bases up there as well. This, this, that, 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 and that's it. Okay, let's try this. So once you log in, you should be able to see that those extra videos have been posted to our classroom. Okay. How did we do? What number did we put? So any extra values here? Hopefully you put a 2 in front of that KOH. This multiplies this whole thing by 2. So that gives us now 4 hydrogens and 2 oxygens and 2 potassiums. And then on the other side, we can catch up by putting a 2 in front of here, which gives us 4 hydrogens and 2 oxygens.
And you would also have to go to the other tank for another 2.
Yeah, very good. I was just waiting to see if you guys catch my mistake. And that would give me my last 2 potassiums.
So we were both on the same page.
All right. So that's that. Oh, and we said this was a single replacement, right? Single replacement. This one was our double replacement. I think this is probably a good, let's see if we can. All right, we're just gonna look at this last little piece here. This is an environmental chemistry connection here. So ozone, especially those of you who are around from a time when there was a hole in our ozone layer, we would have, well, this was a huge deal at a certain time in our Earth's history. Ozone is a chemical we find up in the upper atmosphere of our planet. It is a chemical made of 3 oxygen molecules, 3 oxygen atoms connected together. I'll leave you some extra time to go back and work on those balancings in a minute. So ozone layer is the upper level of the ozone is good ozone. The upper level of ozone layer is a layer of ozone gas that surrounds the Earth. It's about 15 to 35 kilometers above the surface. And at this level in the atmosphere, ozone is able to filter out high energy. It absorbs ultraviolet radiation essentially and reflects it back into space. So it keeps some of the ultraviolet radiation from the sun from hitting the Earth. And ozone collects all around the globe, and it's at the edge of the atmosphere. The ozone at this level is far enough from us that we do not breathe it in. Breathing in ozone is not good for you. So it leaves us free from its harmful effects. But chemicals released into our atmosphere may interact with the ozone, particularly chlorofluorocarbons, CFCs. What do you think about this name? Chlorofluorocarbons. What do you suppose might be the elemental composition of those chemicals? Yeah, CFCs were essentially chlorine, fluorine, and carbon all together. So they were chemicals made with chlorine, fluorine, and carbon. Does anybody know where they were used? They were used a lot in pre-1990 so. Refrigeration was the big deal. So if you have very old refrigerator or very old air conditioner, there's a possibility that you still have chlorofluorocarbons in those. Part of the problem was that those machines, as they broke down, they would have leaks of the gases inside, or people they just drop your fridge off at the dump, right? And then they would get crushed under some stuff, and the containers would break open, and the gas would release. Or one day your fridge doesn't work anymore, and it's because it's leaked out all of its chlorofluorocarbons. So they would actually these chemicals rise up into the sky, and they release their chlorine, forming which can react with the ozone. So when ultraviolet radiation hits the CFCs, they break down or decompose, right? Decomposition reaction, and that gives off chlorine atoms. And these chlorine atoms and ClO molecules can then react with the ozone in the environment. So, for example, chlorine here plus ozone gives us ClO plus O2, chlorine monoxide. Chlorine monoxide plus oxygen can give us chlorine and oxygen. And the net result is that if you do a little bit of adding here, we realize that the chlorine monoxide is produced and used up, and the chlorine is produced and used up. So the end result is a ozone plus oxygen producing O2.
Is it because those gases combining together, is that why we don't have the dust particles like Mars does?
Not so much. The ozone layer is really important to making our planet livable. Another planet without an ozone layer at the same distance from the sun could be so hot that water would boil, and then we wouldn't have any water. And so that's where somewhere like Mars doesn't have water. It's because Mars is not quite big enough to gather enough ozone or gather enough gases to protect it from the sun. Yeah, so that's one of the reasons that the planets like Venus are really, really hot, is because they have very thick ozone layers, or very thick layers of gases, and then they trap lots of heat. But Earth has just the right amount of gases in their atmosphere to keep the planet fairly warm, that life and water can sustain itself.
And plus, I think Saturn has that heat because it has all those rocks around it.
Mm-hmm.
Has that.
And you get a lot of heat trapped inside, yeah. So you get a little bit of energy for that heats up the planet from the actual molten core, but then most of the heat comes from the outside. So part of the problem that created the ozone holes, this is part of the problem that created the ozone hole. So the ozone hole was a really big deal in the early 90s for sure. We talked that there was a lot of monitoring the size of the ozone hole over the Arctic. There was essentially a space where these CFCs would gather and they'd break down. One of the things that's interesting is that Cl went in and Cl came out. So the chlorine never got used up. So as we kept pumping CFCs into our environment, it stuck around. And it kept getting, it never gets used up, but the ozone does. So the ozone gets converted to regular oxygen, which is not good at reflecting the UV. And the chlorine does not get used up, so it keeps breaking down. So it becomes a sort of cascading reaction where the chlorine is stuck in the environment, it doesn't go anywhere, and the ozone breaks down. And so these holes were predicted to get bigger and bigger as long as we kept producing more and more CFCs. So CFCs were banned in the 90s, and since that point, the ozone holes have actually recovered, and I believe they're now much smaller than they were even 20 years ago. So now this has become almost a moot point. It's not even it's not nearly as important as the amount of carbon dioxide we pump in the environment, which is much more. It's a different problem we have now. So now our heat is coming from the greenhouse effect as opposed to extra ultraviolet radiation, which was what was going to be the problem here. So that's enough for today. This live stream is going to end right now, and then tomorrow there'll be another one up. If you are feeling at all sick and you have access to YouTube, this is probably where you should be. Just be at home watching it on YouTube. Wash your hands, keep your social distances, stay safe, and we will talk to you tomorrow.
Still find that funny. How are you?
I-